Okay, in this video I'm going to show you several problems on variable length subnet masks, and I'm going to hopefully show you that this is fairly straightforward. And the idea is we're going to start with a Class C network, and we're going to use variable length subnet masking. So when we start with a Class C, we've got a /24 to start with. That leaves us 8 bits with which to work to divide up into subnets and host addresses. And basically we've got 256 IP addresses that we can divide up into various size subnets. And the main idea here, if I can find a little bit of room to draw this picture, the main idea here is that we're going to take a block of 256 IP addresses and we're going to divide it up into multiple pieces. Okay, so if we start with 256, we can divide that up into 2 times 128, 4 times 64, 8 times 32. So here's 256 addresses in a single block, 2 blocks of 128, 4 blocks of 64, 8 blocks of 32, 16 blocks of 16, 32 blocks of 8, and I'm getting to the point where it doesn't make much sense to try to draw it anymore. In any case, this is the picture that you should have in your mind as you try to do variable length subnet masking. And so, for example, you might find a situation where 2 blocks of 64, a block of 32, and 2, 3, 4 blocks of 16, and then 1, 2, 3, 4 blocks of 8 might accommodate a particular need. Honestly, if you're trying to cram all these IP, if you're really short on IP address space, you might want to just go to a Class A 10.0.0.0. But these are the types of problems that appear on CCNA exams fairly regularly, so you'll want to make sure you know how to do them. In any case, problem 11 here has 5 different examples of that. And the first one is we want 3 subnets that need 80, 60, and 50 host IP addresses each. And with 80, 60, and 50, if we look at the numbers, here I've made a table that shows various combinations that are possible. Here's a 126, a 62, and a 62. This is the 128 and 2 64s, but I've subtracted 2 from each to show how it can fit. And in fact, the 80 will fit in the 128, the 126, and the 60 and the 50 will both fit within the 62. So configuration 3 is what I said yes for the part A there. And for part A, I said, okay, the first one is going to be 128 wide from 0 then to 128. And then we have a 64 from 128 to 192. And then a third one is also 64 from 192 up to 256. And so these are the 3 subnets. And you have to be a little bit careful in coming up with the first host IP. The broadcast is subtracting 1 from the next subnet ID. First and last, fairly straightforward. The width of this one is 128, then 64 and 64, and we need 80, 60, and 50, and so you can see they fit. Okay. Part B asks for 5 subnets with widths 95, 25, 25, 25, and 25. Can we do it? I think this problem starts off by saying none of them can use fixed length subnet masking, and we're supposed to figure out whether or not they can use variable length subnet masking instead. It turns out it's a yes for all of them, and I show that here. For part B, 5 subnets. what I'm going to do is I'm going to use configuration 8 here, which is a 128 and then 4 32s. So 4 times 32 is another 128. So we've got a total of 256 here. And the 25s all fit within the 30, and the 95 fits within the 126. So configuration 8. And what we're going to do is we're going to start with one of width 128, 0 to 128, and then we're going to jump by 32, so 160, 192, 224. So we have 4 of them of width 32 and 1 of them of width I think that's supposed to be 64. There's supposed to be a 32 there. Yeah, this is a typo. Let me get this straight. This is supposed to be a 32. From 128 to 160 is 32. So a 128 and 4 32s works for that configuration, and you can figure out all the subnet IDs from those. So here the increments aren't equal, basically. Okay, as you make the subnet IDs, you have to have variable increments. You can't just put in any increments you want, though. You got to watch out, and that's why it's so important to start with the largest one first, and then to smaller and smaller increments. You'll notice that on these, I always start with the larger one, and then work my way down to smaller ones, and that's to ensure that you never end up with the wrong place in your diagram. So for example, this one, part B, looks like this. If we start with a width of 256, we get 2 128s, we get 4 64s, and we get 8 32s, right? And so in this one, what we're doing is we're using a 128, and then we're using 4 32s. There's the picture you have. Now you got to watch out. If you wanted to use a 32 first and then a 128, it wouldn't work, because you can't start a 128 on address 33. Okay, just doesn't work. You won't have all zeros after that last one in your masks. So you have to start a 128 on either 0 or 128. You have to start all your subnets with 64 on multiples of 64. Starting with the largest and going to the smallest ensures that you do that. Okay, let me move through the rest of them here. Part C, 120, 35, 25, 15. I think I can do it. In part C, what I'm going to do is do a 128 and a 64 and then 2 35s. So I'm going to have a 126, a 62, and 2 30s, and it works. And so part C looks like this. 256, 128, 64, and 32. And I'm going to use the ones which are 128 wide first. Then I'm going to use a 64 and 2 32s. 64 and 2 32s. There's the picture for this one. And you can figure out the beginnings here by just incrementing with these. Increment by 128, then by 64, then 32. Okay. Part D. We want a 64, 32, 16, 8, and 8. The 64 won't fit into a width 64, but it'll fit in the 128. So here's a 128, 64, and 2 32s. No, a 128, a 64, a 32, and 2 16s, in fact. So let's draw that picture. And so we're going to have a 128, a 64, a 32, and 2 16s, just to draw the picture quickly. Don't want to belabor the point too much, but I think it's really useful to visualize these variable length subnet mask pictures. Okay, and we're going all the way down to 16 on this picture, I guess. We need to. And so here we're going to start with a 128, and then we're going to go down to a 64, and then a 32, and two 16s. Okay? And you can increment by 128, 64, 32, 16, and 16. Okay? Finally, part E, 63, 31, 666, 6222222. It turns out it does fit. The 63 fits in a 128, the 31 fits in a 62. These fit in 8s, and these all fit in 4s, and it works out. I'm not going to try to draw the picture there on that one, but it works out. Here's the needed number, and here's the width. And let's see, 128 plus 64. These 4 8s give me 32, and these 8 4s also give me 32. So 128, 64, and 2 32s is 120, is the 256. And you just have to go in and figure out all the little increments here, and the first and the broadcast, first and last IP addresses. Okay, I think that does it on this one. Hope that helps.